What is up? All right, I'm gonna try to do this video again before it gets dark, which happened to me last night. I have an old water source heat pump. I've had it for almost a decade. It still ran when we took it out. The facility I used to work in is just a 2-ton with a 3-phase compressor, which comes in handy because I have a VFD hooked up to it. I have a little SureFlow pump hooked up, taking water, about 15 gallons of circulating water I put in this wheelbarrow here. So I got it taking the water from one side and feeding it back in the other. A couple pieces of copper so I can put the pipe clamp thermometers on there so we could get temperatures. Now let's start my recording. Should be able to do picture in picture for us in this video playback. So you can see how this works. So I got about 109 PSI of refrigerant pressure. I'm gonna turn the fan on and turn the reversing valve to cooling mode. So it looks like the inlet and outlet water temperature, I'm getting kind of confused, 58, that's the return air. I'll be able to figure it out once it turns on. We'll see which one goes up, which one goes down. So I think I got just enough water flow. It's going out of that pump through 3/8 tube, so could be restricting it just a little bit, and it might be sucking just a little bit of air because every once in a while I see some air pulling through there. But look at this, it's all dirty in there with leaves and everything back in there. Oh, it's a little dark, but the coil's dirty and everything, so it is what it is. I just literally pulled this out from the side of the house. I mean, look at the screws. This thing was full of water, just sitting there, abandoned. So let's start it up, 60 hertz. Oh, I gotta get my amp meter. 1.5 amps with just a blower. Let's hit run here. You'll watch, this is cool. You will not get the inrush current when the compressor starts. Compressor started. Yeah, there goes the amps. Yeah. It's about 7, it's gonna keep going up. I know I got close to 10 amps yesterday as the water temperature shot up. Turn air, we're about 71 outside, huh? And let's see, one of these is going to drop down probably to 397. Should be the one that's the cold air over there. There it goes, it's dropping. So good, these are in order then. 64 degree water going in, 75 degree water. Already raised the water's already went up 10 degrees. Head pressure's at 218. Now since and we're at 8.6 amps, watch this. Let's kick this sucker up to 80 hertz. 80 hertz. Just kick the amps up to 11.6. Head pressure is going up 240, about 65 suction, so we're still in the ballpark. Now, when this water temperature does get up there, those amps are going to shoot up. And now we have a 67 degree water with 96 degree leaving water, 97, so you keep shooting up. Head pressure is even. Should I dare even speed this up to 85 hertz? Now this compressor, you know, runs 60 hertz from the factory. We're running at 85 now. We're just gonna crank it up just to see what it does for performance. It might not actually do it any good to do that, but about 13.8 amps. And it's cranking along. I'm sure this water, you could feel it's gonna be warm now. Oh yeah, that's already getting too hot to hold. 105 degrees, probably got just a couple second delay of what you're reading on the copper, you know, from what the water is with the heat, the rise. Don't want to knock anything loose. 107 degrees, 289, 290 on the high side. Back that down to 80 hertz. I'm just simulating what a homemade control could do if I wanted to heat water with this thing in my garage. Supply air, 50 degrees. Return air, 70 right here. So 20 degree split, 300 psi R22 over 69 suction. The suction is not dropping like a rock, it's actually way up there. So it's probably delivering water temperature very well. So now we're up to 72 degree water with 110 degree leaving water. So I forgot to look at the clock. So 5:50, it's probably been a couple minutes now, 2 minutes or so. I want to see how long it takes to heat up 15 gallons of water with something like this. Run at 13 amps. 13 amps. Remember, your water heater pulls 20 amps to run one of those 5K heaters, and it only runs one heater at a time. But heat pumps, you know, they're usually way more efficient. So let's do an experiment now. So I got 110 leaving. Let me start slowing this down and see if I start losing. We'll go back to 60, see if my outlet maintains or if it drops. Because maybe it's pointless to overdrive the compressor. Still got a heat rise. 315, 316 over 69. As the water temperature, you know, in the circulation goes up, which will be, you know, when I get up to about 110, probably have to throttle that compressor back a little ways. You know, and of course, if I actually made something like this to heat up the water heater, you probably want to put maybe twice the gallons per minute through the heat exchanger if that does any good. So I actually lost a little bit of performance going down to 60 hertz. It's down to 110 degree water leaving. So it does in fact do better. Let's go to 80. Now I'll have to keep throttling this. Yesterday I got this sucker over 400 PSI on the high side before I throttled it back. Since I'm driving the compressor direct with the VFD right now, there's no safeties. It could hit 500 PSI for all it cares, and it's not going to stop not until it trips a VFD or something. You know, the compressor locks or explodes. It's going to trip the VFD, I'm sure. 327 on the high side. Now I did this experiment with I took out one of these used heat pumps and I stuck a water to air or refrigerator to water heat exchanger on it, ran it in heating mode, which basically made this part the evaporator, and I was heating water with it, heating 20 gallons into like a storage tank, and it heated up pretty quick. It was like a 3.5 ton compressor, but I did run that up pretty close to 400, about 400 PSI is what it was running. No VFD, it's just what it ran when I got the water that hot. And it heated up water to 20 gallons of water up to 130 degrees pretty quick. Again, this is just a 2-ton unit, you know. Water's still pretty cool. Whoa, it's hot. You can't hold your hand in there leaving. 116 degrees, 117. So it's probably about 120 actually coming out here with the little delay in the reading on their heat rise. So that's hot. Hot. You know. I'd always also be curious to use something like a heat pump to deliver instant water to like a shower or something, because that volume of water right there coming out, taking in 70, well now it's up to 85, but you know, with the slow rate and going through a shower head, you could instantly heat water for a hot shower, easy, with a compressor, you know, so you don't have to do a zillion heating elements like people do with those instant on-demand heaters. So we're running about 340 something with 80 hertz. Let's get out here and see what all our readings are. 7.5 amps, that's, you know, going to the compressor, 3-phase. 13.2 amps total. So 1.5 is for the fan, so it brings us down to about 11.8 or something amps the compressor's drawn on the single phase input. 360 high side, 121 leaving, 87 to 88. So it's heating this water fast right now. This is officially in kick-ass mode, heating this water up. Because it started out at 64, 66, whatever that was, not too long ago, about 8 minutes ago. And it's approaching 90, and the heat rise I think is actually quicker now than it was. Not to mention this is open and not insulated, so no thermal barriers. So I'm heating up an open container of water, so you're losing heat. If this was a insulated tank like your water heater, performance would be even better, by quite a bit perhaps, because it's probably that's a lot of open surface area for that water. So yeah, we're heating it up nicely. 367. Let's see. Let's kick this up to 85 again. 85 hertz. You like to listen to that compressor. That thing from the factory is meant for 60 hertz. Oh, I just heard high pressure click, I think. Safety click, and it didn't stop. Because we have exceeded 380 PSI. It's kind of ramping up there now. But I just want to see what the performance does. 93 degree return water, 125 degree discharge. Yeah. We got 30-degree rise. That's perfect. Getting about 387. Drop down a few hertz. 13.8 amps over there. Return air is 70 degrees, 23% humidity out here. Yeah, and our leaving air is 50 degrees, so we're doing 21-degree temperature drop. Still doing 31 degree rise on the water temp. 392. Drop this down to 80 hertz. 96 degrees. Taking a bit longer than it was at the 5 gallons last night. 3 times as much water and a lot more surface area to lose heat. Oh, I mean, the whole thing's probably losing heat. But it's definitely hot coming out when you're discharging 129 degrees of water. Almost up to 100 gallons. Now, 110 gallons is good enough to heat up a water heater. 120 makes it nice. This is capable of heating it up to 130. Oh, 400 plus PSI. I'm gonna throttle this back a little bit. Now, if I build a homemade controller for something like this to, like, you know, heat up water efficiently in kick-ass mode, you know, I would probably clamp on, probably do it off a temperature, which could correspond with the, you know, PSI a little bit. Don't have to use a pressure transducer. I'll just put on a probe on the outlet water, just trying to regulate it. 130 degree discharge, which should be able to throttle down. I keep throttling down my hand right now just to kind of see where we're at. 400 PSI. I mean, you might cringe at that, but that's what you got to do if you want a lot of hot water. These things are made to take in 80 degree water and put out about 95. And we're already taking in 103 degree water and discharging 131, 132 right now. Pressure's still going up. I'm just kind of trying to keep this sucker down. Oops, what'd I do? 70. There it goes. Starting. Letting the head pressure run away from me. Let's go down to 60. It's kind of funny when it sounds so slow now, and I just dropped the compressor down to 60 hertz. It's design frequency. All right, we're getting a little closer to 400 there. So all the water's 106. We're almost reached, you know, usable water temperature. Oh yeah, the whole thing's warm and it's hot enough to scald you coming out. Put my hand in water and I'm touching shit. 59. Oh, wait, it already dropped below 400 there. So I'll leave it at 60 hertz right now. So far our experiment's showing me that I can ramp this thing up when the water's cold. It's actually dropped down to 385, so let me go back up a little bit. 63 hertz. Sun is going down. So, 418. Ooh, it's pretty sensitive right there. 62 degrees, 62 hertz. 62 hertz. This guy's starting to drop a little bit. Wow, that 1 hertz is going to make that much difference? Come on. Running down to 11 amps. Nice. So it's about almost down to half of what your water heater would be pulling. We've got the water up to 112 degrees and 133 leaving water, so it's still heating up. The hotter I get that, the more heat loss I'm getting to the 71 degree outdoor air right now. And yes, it's 71 degrees at 5:30 p.m. You know, almost on February 27th or whatever it is here in Arizona. The other benefit, if you haven't realized by now, is installing something like this on a shelf in my garage. Is it was blowing 50 degree air out. Now it's actually lost a little bit of performance. 70 in and and 54 out. It was like 21 when I had the compressor ramped up. We're at 432 on the high side. Now when you do get the discharge gas way too hot, you will start losing performance. You might even start getting gas bubbles, you know. It's down to 60 hertz here. You might be getting gas bubbles, you know, maybe even, I don't know, if you're not, as this water's that hot, might not be completely condensed refrigerant going back over to the TXV, which this has. You could start losing performance. All right, it's dropping. It's always way up there. Again, 116 degree water. That would be almost good enough for a set point. A lot of set points are about 110 degrees, I believe, on the water heater, and then the higher set point is like 120, which is what a lot of us crank it up to. Oh, that's scalding hot, but yeah, I mean, that's getting there. 120. I might even heat up to 125, you know. Again, I probably need to, that water, when that water's 120 degrees, I need to move it faster than this pump is probably doing. So I'd probably have to get a, figure out what the gallons per minute on that is, probably get like double that. Oop, head pressure's running away from me again. We're actually gonna have to drop below 60 hertz right now. If I hook up a control, so we got 137 degree leaving water. If I had a controller on here, it could automatically modulate it. I wouldn't have to watch it like this. Okay, my screen capture's been going for 17 minutes, I guess. But I did start this several minutes before I started the compressor. So in the video edit, we'll see how long it took. But we're now at 120 degrees, so it's done. So 15 gallons heated up in probably less than 15 minutes from 70 degrees. We're all, oh shoot, we're up to 122, leaving 138. So we're fully warmed up. So I think the performance would be way better if this was an insulated tank. Don't you guys think? Than this test is right here. That's got to be losing a lot of heat that I'm creating with this, just right out into the air, you know, being open like that. Plus this is spraying out in the open, but I pulled it back because I wanted to see the flow and I wanted to measure the temperature right there. So it's hot. That would be a really hot bath. I can hold my hand in it. So 123 degrees. I know 130 is that point I've noticed right where I can't keep my hand in it. Could do it for a few seconds. So 447 high side. So once this thing got up towards target temperature, I really would have to start backing the compressor off. And I could see with it being that hot, I'm losing performance. I'm cooling. 70 degree, 71 degree turn air, and 57 supply. This thing is, yeah, not too happy about that. Now I'm under speeding the compressor, so it's actually losing its BTUs. Got 430 something on the high side from that hot water. It's feeding in 125 degrees and 85 PSI. So we're down on performance at this point. So at the upper end of heating up that, you're gonna lose performance. Maybe if the water hauls ass to the heat exchanger, you'd be able to do it. I mean, this isn't designed for that water temperature. But the reason I made me even think about these, heating up a water heater, was when I worked on these over the years, and you get reduced water flow, and it's like 70, 80 degrees. Uh-oh, that thing stopped. Did it just fault? Compressor overheated inside. Wow. Look at this thing, it's pissed now. It's like, I don't think it's detecting. There we go, stop. I think I just heard it click. Wow, compressor actually overheated. I didn't slow it down fast enough. But yep, there we go. We have almost 130 degree water in that wheelbarrow, 127. See the leaving water is coming down to equal that. Head pressure's dropping. Pretty sure the compressor won't start. Probably overheated. That, which means I can't do my other test right now of definitely would have to try another experiment with more gallons per minute. Keep the compressor pressure down a little bit. Of course, I could also try it again without overrunning the compressor in speed. Anyway, you can see the water temperatures. It was like up to 130 or whatever. It's already lost 6 degrees. You see it's losing water temperature pretty quick. So I'm losing losing temperature to the open air. Running out of light. Took a while for this to cool off. I just took off all my gauges, everything, and now it just started a second ago. There it goes. Yeah, it seems like the compressor might be just a little on the tight side. It might need some snake oil. Might need to add some zero ice or that AC renew to it. Yeah. So I didn't get the water temperature. It's warm still. Definitely not 130 degrees anymore. So anyway, it looks like I gotta call it a night. Disconnect this wiring from my disconnect over there. Get this all cleaned up. But yeah. One sort of successful experiment. It'd be good to actually have this sucker hooked up to the water heater that's insulated and kind of seeing how it could perform. Watch a longer curve on it. But so far as you see, you know, a lot of the times this thing's only running about 10, 11 amps. It was only running a little more like 12 or so when I really overran the compressor. So at 60 hertz, and with the water temperature, you know, cold, like about 70 or so, I think it was still only pulling 8, 9 amps, which pretty decent heat rise, and that's definitely way more efficient than straight electric heat. These things, it would be like 24,000 BTUs. Rejecting heat wise, you know, they're pretty efficient, and then, you know, it's probably doing, you know, a little under 20,000 BTUs of actual sensible cooling into the space that this would be installed. So kind of cool the garage a little bit whenever it was running, if I install this bastard. It's one of those things I've talked about for a decade, or more, actually more than a decade. I thought about it about 2005 or so when I first started working on water source heat pumps. Just it's an idea. It would definitely be a bastard. Who knows when I'll do another update on that, but I just thought that was kind of fun to do. It's getting dark, but be sure and like and subscribe to the channel. Catch you guys later. What you doing, Mutt? What you doing, Mutt? What you doing? Get down.